Welcome back, Patriots. Time for us to start working on section 7-3. First off, the reason why things look different this time around is because I'm recording from home this weekend and I don't have all of my green screen set up here. So that's also why you're looking at this fun little graphic in the background. Not nearly as cool as that Patriot flag I usually have, but that's actually the visual aid I use with my kids trying to teach them how to type. So anyway, let's go ahead and get started on this. So far we've talked about 7.1 and 7.2. Section 7.1 was proportionality and ratios. We learned how to cross multiply and solve. Last time we talked about section 7.2, which was similar polygons, and we really focused in on matching up corresponding sides needing to be proportional. And we're coming with that idea again today. Now remember, once again, this symbol here means proportional. And then this sign is congruent. So let's go ahead and move on with this. We're going to be focusing specifically on similar triangles today, and very similar to what happened in the congruent triangle section in the last unit, we are going to have certain postulates or patterns that we notice within our sets of triangles to know whether or not they are similar. Now, if you remember back from the congruent triangle section, there were 4 different ones that we were allowed to use, and those were side, side, side congruence, side, angle, side congruence, angle, side, angle congruence, and angle, angle, side congruence. The ones that did not work were side, side, angle, and also angle, angle, angle. Those two did not work. This one because it allowed for both an acute and an obtuse that both fit the side, side, angle, and this one because it allowed for dilations. Now, actually, that is kind of where we're going to start in today, because dilations, when we're talking about similar figures, while they don't work for congruent triangles, they definitely work for similar triangles. Because the thing about similar triangles is that they are the exact same shape, but different sizes. So these two triangles are similar because all their corresponding sets of sides are proportional. All their corresponding sets of angles are congruent. So we know that this angle and this angle are going to be the same. This one and this one are the same, and these two are the same. Our corresponding angles are congruent to each other. We also know that this angle this side is proportional to this one. These sets are proportional, and these sets are proportional. Now remember there that this marking I'm using is actually kind of a misuse of it, because in reality this would actually mean these two are congruent. I'm actually just trying to indicate right now that they are proportional to each other, but please forgive me on that. I'm just looking for notation that'll give you the idea. Okay, now in theory we would have to know that before we can determine that two triangles are similar, we would have to know that all 3 sets of angles are congruent and all 3 sets of sides are proportional. However, in this case, when we're dealing with triangles, there are 3 special shortcuts that are our triangle similarity postulates. Now, those are the first one is the side, side, side congruency postulate. Now here, we're not saying that the sides are congruent like we said up here. This means that corresponding sides are proportional. Okay? So what that means is if I walk in and saw 2 triangles, and let's just use 2 simple ones here. Let's use, well, I'm not going to put that right angle there. But anyway, this one was 3, 6, and 8. And then this one was exactly double that, where this one was 6, 12, and 16. Well, these would be would be similar triangles because we have the exact same scale factor. 3 over 6 is 1/2, 8 over 16 is 1/2, and 6 over 12 is 1/2. Just like we did with that similar polygon section last time. Our second one is the angle similarity postulate. Now in this case, corresponding angles must be congruent. Now, the reason this is not angle, angle, angle is because since all 3 angles must add to 180 degrees, if I know 2 angles, then I definitely also know the third side. All I have to do is subtract these 2 from 180. So in theory, there's that other A here. I mean, I honestly wouldn't even write it just because these 2 tell you the other one. it's sufficient to know just that two angles are congruent, and it automatically knows the third one is. Okay, so another example on this is if we knew that this angle was 40, this angle was 110, this one was 40, and this one was 110. I would then know that these two are similar. And yes, I know it's not drawn to scale. All right, and then our last triangle congruency postulate, triangle similarity postulate is side, angle, side. Now, once again, just like the S's up here, these are saying the corresponding sides are proportional. Let's use this symbol this time. And just like above, we're also saying the corresponding angles are congruent. Okay, so in this case, we are still looking at the included angle, just like we did for our triangle congruence theorems. So in this case, we would need, if we knew this side and this side, we could not use either of these top two angles. We would have to use this bottom one in order for it to work. Okay, before we turn the first page, I'm going to go ahead and ask our first question. For triangle congruence theorems, let me say that again. For triangle similarity postulates, should sides be congruent or proportional? And second, for our triangle similarity postulates, should angles be congruent or proportional? All right, good. I really hope you guys got those correct. They were actually on the screen. Sides are proportional, angles are congruent. So let's go ahead and move on to page 2. All right, so here over on page 2, we're going to be practicing just identifying the different postulates and identifying whether or not they are similar. And over here on page 3, we're going to be actually practicing doing some solving for x when we know that they are similar. So first off, determine if they are similar, and if so, write a similarity statement. Now here in example 1, we're also kind of using that misuse of the hash mark notation again. Actually, no, I'm wrong, actually. These two are congruent, and those two are congruent. I'm sorry, I read that one entirely wrong. So, at first glance here, I only have that these two sides equal, these two sides equal. Now, I know that because of that, these two, the top two and the bottom two, are going to be proportional to each other. Because, let's just throw some variables in there, x and y. Since this side is x with 2 hashes, this would also be x, and this would also be y. And so if I set up the proportion there, it's going to be x over y x over y for this top one. The bottom one will also be x over y, and you can see those are the exact same fraction, meaning they have the same scale factor, and therefore they are proportional. However, in order to use my postulates, I need either a third side, two angles, or the included angle. So I'm hoping you're actually seeing this already. Since these two are vertical angles, I know that they are congruent even though they are not marked. So these two are going to be equal, which does give me a side angle side relationship. So because I have two sets of sides that are proportional, and I have one set of congruent angles, the included angle is congruent, that means that they are similar. So I'm going to go ahead and write that similarity statement. Sorry, my printer's going haywire over there. Now remember, the first triangle, write it any order that you want. I'm just going to write ADE is similar to, and then I ran out of room there, but because there's my fold. That's going to be similar to ADE, and we're going to have to put in all of these in the appropriate order. Now the important thing here is that we make sure we're going the right direction. So angle E is congruent to itself, so since E is third, E must also be third here. Now in this case, because these two are equal to each other, they're both isosceles, it's not going to make one bit of difference if I put the A or D first, the B or C first, but if it wasn't isosceles, I would have to make sure that I kept track of which side went where. And we'll get more practice on that down here. So, and then this is by, side, angle, side. There we go. Triangle ADE is similar to triangle BCE by, side, angle, side. All right, now let's look at example number 2. Well, I can see that I have no sides marked or no sides measured, so I'm definitely not going to be able to use side, 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 or side, angle, side. My only possibility here is angle, angle. Well, I can definitely see that angle Z and angle W are congruent, so that is one piece. However, I can see that angle X and angle T are not congruent. Now, a lot of students just stop right there and say, well, 34 and 54 are not the exact same thing. But we've got to go through and check the third angle. It doesn't matter which one you use, but let's go ahead and check it. Now, the measure of angle Y here is going to be, well, 180 minus 90 minus 34. That's going to be 56 degrees. Okay? Now, 56 does not match 54, so this is not similar. Okay? Now, that actually was, whenever I wrote it, I intended to put a 56 there, but we'll just go with that. It's not similar. Okay, now example 3. When I'm looking at this one, the first thing I'm noticing is that I have absolutely no angles marked, which means I cannot use angle, angle. I cannot use side, angle, side. The only one I have a possibility of using is side, side, side. So what we want to do is go ahead and figure out which of these pieces are going to match up and correspond with one another. Now, the easiest way of doing this, instead of just randomly checking them, is go for the shortest side of each triangle first and make a reduced ratio out of it. Then go for the middle side and then the longest sides. That way I'm guaranteed to get the correct pairs. So if I'm looking at this triangle, I see that the 3 is the shortest one. And on this triangle, I see that 3.6 is the shortest one. So let's start with our short sides. 3 divided by 3.6. Now we need to try and reduce that, and you can do that if you want to. Let me go ahead and show you the easy way of reducing fractions on a calculator. 3 divided by 3.6, if you'll go ahead and press Math, Enter, Enter, it will reduce the fraction for you, which in this case is 5/6. Okay, now let's go to our medium side, which looks like here medium is 4, and on this one is 4.8. So you got 4 divided by 5, 4.8 is equal to 4 divided by 4.8. Oh, Math, Enter, Enter. Once again gives me 5/6. So these two are proportional to one another. Now remember, all it takes is one that's not. So if these had not been the same one, I would be done. I could say not proportional. However, let's go ahead and check the long side. So my leftover one's 6 and 7.4. So 6 divided by 7.4. Math, Enter, Enter. Comes out to 30/37. Which we can see is definitely not equal to those. So because this fraction and this reduced ratio is not the same as these, they don't have the same scale factor, and therefore this is not similar. And yes, that one was intentional. If I wanted it to be similar, it would have had to have been 7.2 right there. Okay, moving on. Example 4, identify the similar triangles and then find the value of x. So first off, I'm going to look at these two and say, are they similar to each other? Because if not, we can't do any math whatsoever. Well, I've got the angle J is congruent to angle K, and even though it's not marked, I know that angle JMS is congruent to triangle KMD. So I do have an angle-angle similarity. Now let's go ahead and write this in, because I promise you we get to practice that a little bit later. And later is now. So first one doesn't pick up, just pick up which one you want. I'm going to do JMS. And now for this next one, I know that the angle M's are equal to each other, so the M has to be in the middle. J is in the first position, and J corresponds with K since it's congruent, so K must also go in first position. and then therefore D will be the last one. Okay, now as far as what to do with that, we've got two sets of sides that are marked here, and it looks like I've got JM. JM is in first and second position, is going to correspond with KM. So I'm going to make my fraction 12 over 15, JM and KM, equals, and then let's do our other set. Looks like for my left-hand triangle, oh yeah, I forgot, always going to do this. It's going to be the left-hand triangle divided by the right-hand triangle. So 12 was on the left-hand triangle, so it goes on top. 15 was the right-hand triangle, goes on bottom. Over here I've also got JS, which is my wraparound here. JS here is KD, so this one. So JS is K plus 1. The left triangle goes on top. Right triangle, X plus 5, goes on bottom. And now let's go ahead and cross multiply and solve this. That gives me 15 times X plus 1 equals 12 times X plus 5. Now we're going to distribute this across. It gives me 15x plus 15 equals, here we've got 12x plus 60. So now we need to subtract the 12x on both sides. That's going to leave me with a 3x. We're also going to subtract 15 on both sides, and 60 minus 15 is 45. Now let's divide both sides by 3, and that's going to leave me with x equals 15. Now in this case, the value of x is what it's asking for, so we are finished with the problem. Now just be careful with that, because it's possible that we actually ask you to find the value of KD or JS and be willing to plug it back in there. Okay, last example, example 5. Now, this is the type of problem that gives students a lot of problems, because the two triangles that are similar are actually directly on top of each other. And so what I always suggest doing is rewriting all of our information, but pulling the two triangles out into separate drawings. So I'm going to draw two different triangles. I have this one and this one. Now this piece is a larger one, which is TLN. And this piece here is the smaller one, which is MPN. Now, I'm going to go ahead and mark, just like we did with our congruency, any angles that were exactly equal. I want to go ahead and mark those because these two angle ends originally were both right here. So they're going to be congruent to each other. Now we've got to see if we know anything else on this, or any other sets of angles that are equal. Now, this line TN and the lines LT and PM, since these two are parallel to one another, and line NT acts as a transversal line, then remember in our transversals, our corresponding angles are going to be congruent to each other. So here angle T is a 2-mark angle, and angle PMN is a 2-mark angle, which means I do have a triangle similarity statement. So let's go ahead and write that. Let's go with triangle LTN is congruent to triangle blank by angle. Now I'm going to let you fill this one for your next question. What 3 letters should go here? Keep in mind we have LTN going first, so what should the name of this triangle be? Alright, moving forward, let's go ahead and check that for you. L corresponded with P, T corresponded with M, and N corresponded with N. So you should have had PMN. Alright, now for solving for X. Let's go ahead and start filling in what we know. So this piece from N to M is 6x plus 2. Now, from N to T is this full distance, which means we've got 6x plus x is 7x. 2 plus 5 is plus 7. So this is 5x plus 7. Again, that came from combining these two together. Now, to find the value of NP, we're actually going to have to subtract 8 from 24. since 24 is the full distance from L to N. 24 minus 8 is going to give me 16 here. So NP is 16, and then LN was the full distance of 24. And now I can set up my proportion. Just to be clear on something, in lesson 7-2, I kind of made it appear like you always had to reduce these fractions of the scale factor. Like, for example, right here, you had to reduce that down before you could set the proportion. Honestly, it doesn't matter. You can do that, but you don't have to. We can just use the straight sides like I did on this one. So if that was confusing you, I apologize. I should have said that earlier. All right. So up here, again, we're going to do left triangle divided by right triangle. The left triangle, let's go with the tops first, is 7x plus 7 over 6x plus 2 equals 24 over 16. Always putting the left one on top and the right one on bottom. Okay, now I could go ahead and distribute this across. That's going to give me some really large numbers though. I'm going to choose to go ahead and reduce this first just to make it a little bit easier. 24 divided by 16. I should do that in my head. Oh well. This is going to be 3 halves. All right, now let's go ahead and multiply that through. 3 times 6x plus 2 equals 2 times 7x plus 7. Just cross multiply through. Now let's distribute those. That gives me 18x plus 6 equals 14x plus 14. Now, let's subtract 14x on both sides. 18 minus 14 is 4x. Let's subtract 6 on both sides. 14 minus 6 is 8. And then divide both sides by 2 gives me x equals 2. Once again, this directions ask me for the value of x. Therefore, I'm done. Again, always keep in mind to look back for everything, or for whatever it's asking you for. So if it asks you to find a side length, plug the x back in. So, in summary, triangle similarity works very similar to triangle congruent. However, the major difference is that the sides are proportional, not congruent. Angles are still congruent. Good luck on your assignment and your quiz.